Okay, we are on episode 6 at CIMBC 22. We're here in Vancouver doing live shows. A huge part of what makes mining now, educational is that companies come on, they'll give the overview, and then they come back on and they'll update us on projects, or they'll give more technical information, or bring someone new from the company in. And here's a great example of it. Today we are featuring Fenner Dunlop. And we have Bouchard. He is a national sales director. He's been on the show before, but he is bringing in Akiko. I'm going to bring you in because I just learned your last name and I didn't learn it well. So please introduce yourself.
Akiko Wakatsuki.
Wakatsuki.
Yes.
Both of you, welcome to the show. Akiko, you're the senior manager of application engineering. So a lot of these conversations, we're going to start, Carl, I'm going to kick it off to you, and then you can bring in Akiko to sort of fill in some of the blanks and as we walk through it. You've been on the show before,
yes,
but I'd like to sort of give that overview. I mean, Fenner Dunlop's 1861.
Yeah.
I thought someone had actually done a misprint. I thought it was, but it is actually 1861.
Yeah. It's a very old company. We started making conveyor belt in England years ago. So but we are owned by Michelin now. We've been bought out by Michelin in 2018. So we are part of the Michelin group, which is a very good thing for us. It gives us, all the resources that we can get through the group. And we are the only heavyweight conveyor belt manufacturer, I should say, remaining in Canada. So we have a plant in Canada, and we have plant in the U.S. as well.
Well, I mean, Fenner Dunlop was such an established company for a long time. I mean, again, look at the numbers. But now, is it a noticeable change? Were you there? Were you at Fenner Dunlop when it was just Fenner Dunlop before Michelin? No. Okay.
No, I came after the acquisition.
Okay. Have you talked to people that were there before? Does it just expand the capabilities? What are some of the differences from your perspective?
Well, maybe in a more fashionable manner, which these days is supply chain. Now we benefit from all the resources of the group when it comes to sourcing raw material, and using transport and all the resources of the group. So that's one thing. And also on the technical side, Akiko, maybe you can.
Yeah, we have a bi-weekly meeting with their technical department in France, and we talk about all R&D issues, and they will support us when we need it. We do the development together.
Yeah, that's a weekly meeting. That's quite a bit.
Bi-weekly, yes.
Yeah. Bi-weekly. Mm-hmm. And so that's sort of a sharing, it's sort of also a platform to share information and strategy and viewpoint and feedback and all those types of things then, right?
Correct.
When you want to go, I mean, you're talking to the mining industry here, obviously at CIM, and I know there's lots of other aspects of the business, but for mining specifically, what's sort of your message that you want to get out?
Okay, now let's take a moment to thank our sponsors. And first up, we have Optisize. Optisize is a leading-edge geophysical acquisition design and software company. Optisize provides innovative seismic survey designs utilizing the latest field technology and optimizing for advanced processing and quantitative interpretation techniques. Optisize's mission is to bring sustainable exploration solutions to energy development with their custom land footprint reduction technology, EcoSize. EcoSize enables operators to focus on reducing their environmental and greenhouse gas footprint while imaging all their subsurface targets and reducing costs. Visit them at optisize.com to learn more. Next up, we have Fuller Brothers. Fuller Brothers Inc. has over 59 years of tire industry experience as the world's leader in providing non-hazardous, non-toxic products that reduce tire management costs for a diverse range of customers. The acknowledged formula developers of the globally recognized Tire Life. Fuller Brothers also produces other quality products such as PSF Plus, PSF Lubezit Tire Cream, Dripless Tire Paint, Omega Tire Repair System, as well as select tire service tools and tire painting equipment. For more information, you can visit them at fullerbros.com or by calling toll-free at 1-800-547-7785. Fuller Brothers, we have the inside covered. We also have Apex Automation. Looking to solve a problem, Apex Automation has a solution. Their proven track record has helped organizations streamline production and improve team morale by removing mundane tasks and lower operation costs and burdens. Robotics, advanced process control, and machine learning are examples of what Apex Automation can provide. Have an idea and looking for a trusted consultant who can deliver? Contact Apex Automation today and start your team's automation journey. Visit them at apexautomation.ca to learn more. And last but not least, we have General Kinematics. Revolutionize the way you think about screening with General Kinematics STM Screen 2-mass vibratory screen. Using General Kinematics proven 2-mass technology, this innovative screen is capable of handling increased capacities by up to 40%. With 2-mass natural frequency, load surges are no longer a problem. The load-responsive design increases retention time working the material longer, which increases its screen efficiency. All these features combine to provide the most efficient, longest-lasting, and lowest cost of ownership screen in the industry. General Kinematics STM Screen Smarter. Visit them at generalkinematics.com to learn more. Now let's get back to the interview.
Yeah, well, there would be so many things we would like to say to mining company who are using conveyor belt, but let's say we would focus on long conveyor, like long overland conveyor.
Yeah.
So we would like to talk about that. What we would like to say would be that for years now, long conveyor are using steel cord carcasses because the big advantage of a steel cord carcass is to have a very low elongation, so you can carry a lot of material over a long distance with minimal elongation. But over the years, Fenner Dunlop have developed some high-tech weaving fabric where actually we can replace a steel cord belt with a fabric belt. And the advantage of that are numerous, because a steel cord belt, they're very strong on the lengthwise, but they're not very strong when it comes to, rip and tear resistance, because the belt is essentially made of steel cord with rubber spacing,
Right.
between.
Yeah.
So we can replace those belts with our high-tech fabric, our Usflex belt, and the belt will last a lot longer. We will have more rip and tear resistance, more impact resistance. So it's a good way of changing something that have been dealt the same way for years, with something new.
Would an overland, would there be a lot of, I guess another way to ask, would there be more impact than maybe people anticipate on?
Yes and no. Well, on a long conveyor, most of the impact and the wear and tear happens at the chute level. So on a long conveyor, the belt is less, is less often under the chute, because you need the long cycle to go back on the where everything happened. But the thing is, if something, let's say there's a piece of rock or a foreign object that jams somewhere on the belt, it's easier to get ripped. So it's a lot easier to get ripped, and if you rip your belt on the long distance, then it's a major issue, because you have to stop producing and replace the belt.
You sent me a chart. It's Carcass is different. I looked at it, but I think it would be better if you actually kind of outlined what we're looking at. We'll bring it up on the screen for the audience. So what are we actually seeing here on this chart?
Well, it's we are comparing the Usflex Carcass rip resistance, on the crosswise and lengthwise direction, with a regular fabric belt. And so the number on the right, are the Usflex number. So this fabric, this carcass that we are weaving ourselves, it's a proprietary weaving pattern that we weave this fabric in Livonia in Georgia. So this belt, we use this fabric sometimes to protect the cable of a steel cable belt.
Oh, this is in addition. So this is not replacing the belt.
Yeah, well, it could be in addition, or we use this carcass to make the belt itself.
Oh, okay,
So,
I see.
Yeah. So this, and maybe I should have on the Usflex. If you look at the D20, for example, the 2000 PIW belt, we have a customer who they are running a very long overland conveyor. The belt is 44,000 feet, and it's They do that with an Usflex belt.
So what is this? This other so the X series. What are we looking at? We're looking at this graphic coming up. The like purple. There's red underneath. What are we? Because I know you've kind of described it, but with bringing a graphic up, what are we looking at?
We're looking at, well, it's the weaving of the Usflex carcass. So
Okay.
if you look at the let's say the red, the red strand
Yeah.
that goes from left to right. This strand is the one that goes on the what we call the warp side, which is the lengthwise of the belt.
I see. Okay.
And as you can see over there, it's straight. And the weft, which goes crosswise on the belt, is also straight. So those are big AV, let's call them cable,
Yeah.
for the purpose of this discussion. And they're completely straight, and they're running along the belt, or on the cross side, the weft section. So this, though, what we call a straight warp construction. So this belt it's basically, and all those fibers are bind with a heavyweight binder,
Right.
and basically it becomes a ripstop belt. It's a ripstop carcass. If it increases the impact resistance and the tear resistance and the rip and tear resistance of the belt.
Can I ask a question on the? I saw this thing. It's an elastic elongation of only 1% on the Usflex carcass.
Yeah, on the Usflex carcass.
What would the comparison be to, let's say, something from like a different style? Would it be 3%, 5%? Like what would a standard be?
So in the market, the standard carcass is called EP. That's a polyester warp and a nylon weft. Typically, the total elongation of the product is about 1.5 to 2%.
Okay.
And Usflex fits in that range, or depending on the rating, it might go a little bit over, but around that range.
So what would a 2%? What is the difference in result? Is it harder on the motor, skipping? Like what is the result of more stretch?
You have to manage the stretch. So the longer the stretch on the long conveyor, you would need like a very long take up to absorb the stretch.
Right.
So that's why most of those long conveyor have a steel core carcass, because they have a very low stretch.
Right.
So if you have a 2,000 feet conveyor, and if you have 2% stretch, right?
1.5 to 2%.
1.5
Yeah.
to 2% times 2,000 feet. Correct me if I'm wrong. It's 30 feet, right?
Well, if it's 2%, that would be a 40 feet.
40 feet. Yeah, if it's 2%, it's going to
Yeah.
be 40 feet. So
which is a lot of stretch. A lot.
Yeah. And that would be a very short conveyor,
Right.
Yeah, by
Right.
an overland point of view. So, but with the low stretch Usflex, we can manage this, the permanent elongation around 1%, right, Akiko? Once the elastic elongation is
Different weave have a different combination, but total is 1.5 to 2%.
1.5
Permanent
to 2%.
elongation and elastic elongation.
Yeah.
So when you say permanent, does that mean that it will get to a certain point and then it will stop?
Correct.
Well, so it will stretch and it won't recover. And elastic elongation is it will stretch out when the belt is trying to start up, but it will recover when it start running
Right.
at a certain speed.
I'm having so much fun doing this interview because so many guests I really like them. This is way beyond something that you don't talk about belt.
Yeah.
And you're actually going into it. So I hope I'm not staying on it for too long.
No, that's
It's very
fine. That's
interesting.
fine. And in some application, we're going to have to remove the permanent elongation. So the belt might have to be respliced.
Right.
We're going to we're going to shorter the belt to remove the permanent elongation, and at the end, the conveyor will be left with the elastic elongation, which will be around.
Depending on the carcass.
Yeah. But let's say we're using a low stretch Usflex.
0.5 to 1%.
0.5 to 1%,
Yeah.
which is fairly low. When you look at that.
Okay, so I want to. Of course, it's probably clear to other people actually watching that know belts better. But so there's the SD belt you can replace with the X series.
Correct.
So, okay, so
with the Usflex,
with the
which is
S-Flex.
part of the X series.
Right. So how long could it be? Like how long of a belt could you?
Yeah, well, like I said, one of our customer in Canada, they're running a conveyor, a long overland conveyor. The belt itself has 44,000 feet. So it's 22,000 feet long conveyor.
So 1% of that, we're talking 440. No, it's how long? How long is the
Yeah,
belt?
the belt is 44,000 feet.
44,000.
Yeah, 44.
So that belt could stretch
Okay,
400.
440 feet-ish. If it's permanent elongation is 1%.
Wow. So how much over time though? What would it take to get that? I didn't realize it stretched that much.
Yeah,
so
yeah,
that's new information for me.
Yeah.
So how long would that belt be in operation before that would happen? 440 feet.
Depending on the conveyor system, depending on how much startup and stop they do,
Right.
and what's the tension, the maximum tension they reach, how often per day, but it could be like a few weeks to a couple months.
So would there be any disadvantage to replacing? Like if you're replacing this, if you're replacing one of these belts, and I want to get my models right. So we're talking about replacing what belt with what? I just want to get my series right.
We're talking about replacing a steel cord belt
Yes.
with a low stretch Usflex Carcass belt.
Okay.
So that's the what we're talking about. So that's the.
So would there be any reason not to do that?
Well, if Akiko, correct me if I'm wrong, but it would be if we don't have the capacity within the conveyor to manage the elastic elongation. You know, the elongation once the permanent elongation is removed.
Right.
If our take-up is unable to manage the elongation that the belt will have in operation, then it will be difficult to do that.
So typically, they will put mechanical joint, the temporary joint, and then they will keep running until it stretch out to the limit of the take-up system, and then they will cut it off, and then they put another mechanical joint, and they keep running and wait until it stretch out. So they will keep repeating that until the old permanent stretch comes out.
Right.
And if the customer don't want to do that, and they will stick to steel cord belt.
Yeah.
Right. Okay.
But if we manage to do that, then the customer will end up with a belt that is.
You've got a character behind you having some fun.
So
I work with a mining numerical group, so they're a good group actually.
Yeah. No. So once we do that, the customer will have a belt that which will be a lot more resistant to rip and tear, to impact. A belt that will be easier to repair. A belt that will also, if let's say there's a problem with the conveyor, let's say, and the conveyor gets banged by a mobile equipment, or something is not aligning, or some component of the conveyor gets misaligned, the fabric belt will be a lot more forgiving,
right,
than the steel cord belt.
Right.
So there's a lot of good advantage once this is done.
Yeah. Does it take a lot? I mean, obviously you're on here discussing it and getting into quite detail, which is very nice, because I don't think people realize on the show how much people actually want very technical data from our show.
Mm-hmm.
They're after a few minutes, okay, I get the product, now tell me, let's actually dig into it. So I appreciate it. Is there still some hesitancy though, or is there like the tradition of no, I want the steel in the belt? Is there still any of that, or the industry kind of moved it beyond that?
No, well, every application are different.
Right.
So if a customer runs a steel cord belt and they have no, the conveyor is perfectly aligned, they have no frying object, no lumps, no material that gets stuck between the pulleys or the idler, they have no rip and tear risk, let's say. So they are, or they had less rip and tear incident over the years.
Yeah.
They will be less prone to replace their, to
Right.
invest in the replacement of that, because they're going to say, if it ain't broken, don't fix it.
But of course, mining has so much.
Yes.
That's, I mean, if you want nasty material that's going to attack the belt, it'll be
Correct.
mining.
Yeah. No, exactly. Mining are the most demanding application for conveyor belt. So yeah, so if that's the case, well, there's less reason to replace the belt with with an Usflex fabric.
Right. I was seeing a note here that there's it's called like an aramid fibers or something, and it's actually bulletproof. Is that right, Akiko?
Actually, I took some sample and used a gun and shot it, and yes, it stopped the bullet.
Yeah.
This leads to so many other questions. Were you asked to do this? What is this?
I volunteered. I just wanted to see if it stops.
How big of a piece? Did you challenge yourself on the shot? I mean, how big of a target was it?
Well, the target was like 1 foot by foot.
Yeah, be careful because they're going to put that on the internet now.
Oh, okay.
Everybody will know that you use a gun against a conveyor belt.
Oh, I'm in the U.S., so
Yeah.
legal.
Oh, there you go. Hey, I'm a terrible hunter, but I am. So it is what it is.
Yeah, that's
I like them.
Well,
But what? It was in the notes when I saw it. So is that significant that it's actually is bulletproof? Does that give you sort of an idea of how tough the material is?
Yes, so the reason that we wanted to use that fiber is because when you have a sharp object dropping onto the belt with high impact,
Yeah.
it will stop penetrating.
Yeah.
And we sometimes use it by itself, or sometimes we will add the Usflex type of breaker to absorb impact to protect more. And so the belt will last much longer.
Right.
And we can use this in a short belt, with a feeder belt with a lot of impact in a short time, or we can use it in a long overland conveyor because that particular fiber have a very small elongation compared to polyester and nylon.
I see. Well, I mean, I think, though, that you have to do a video demonstration next time you test that. I mean, come on.
The main idea is we have to protect the carcass,
Right.
As much as possible. So that's the goal. If the carcass can be protected for a very long period of time, then the belt will last, for that same amount of time. So everything that have a chance to penetrate the belt, puncture the belt, get stuck, and rip the belt. That's what we need to. To do to protect it. And for the aramid belt, the cord flex, it's not for every application.
Right.
But if you have an application where you have a lot of downtime because of puncture, your belt gets punctured by rocks, by material, then it's worth it because the belt just keep on running.
So would you use that in like an overland conveyor application or not?
We can use on the overland conveyor. There are some application in the world that they replaced steel cord belt because the fiber is actually lighter than the steel cord.
Oh, okay.
So it saves some power.
Right. Well, I wanted to ask about that because I saw this power save belt. Is that kind of what you're referring to there? Or is that a different thing?
So that one is from the Carcass. They try to save power consumption from the belt weight. But we have a compound called the Power Saver. And we've been developing this one, trying to tweak and make it better with Michelin, because Michelin is big on the sustainability and they have power consumption tires. Mm-hmm. And so we're using that technology, and then they're helping us develop better compound. And so if you use this compound, it will save power consumption of the overland conveyor up to 30%.
Really? Mm-hmm. Wow.
Which is significant.
Yeah. Mm-hmm. Yeah. I wanted to go, so you touched on it earlier, and I want to kind of circle back to it. Now, if someone needs to stick with the ST belt, though, then you're getting into the...
with the Usflex breaker. If they want to keep running an ST belt, we can use the Usflex breaker that will help protect the cable. So it's like a best of both worlds,
right?
Because you have the low elongation of a steel cord, but you have the Usflex breaker, which will help protect the belt against puncture, rip and tear, and will also protect the cable from impact.
So that fabric will absorb the impact, and that it's protecting the steel cord. And at the same time, weft will prevent or minimize the rip and tear resistance. impact.
Right.
Yeah.
Right.
So,
I see. Now, before we wrap up the interview, I wanted to talk. I think we've touched on it before a little bit, but I wanted to kind of go back to it. The eagle eye images.
Correct.
Can you talk a little bit? I mean, it's been a while. Can you sort of update of sort of where it's at? And I mean, this is fully available to your customers.
Correct.
Right? Yeah.
Correct. Well, there's the Eagle Eye have been there for a long time. We've been improving it. So the Eagle Eye is a system that will monitor the steel cord condition. So we send a magnetic field inside the belt, and then we read that magnetic flux, leakage. That's MFL, what we call MFL. And based on this reading, we will know the steel cord condition. So we'll have steel cord condition, splice condition, overall impact damages. We can monitor the health of the conveyor belt, in real time. So that has been there for a while, and it's working very well. The thing that we wanted to improve, we wanted to improve the how do we communicate the data to the customer, to the user, because it's something that those systems generates a lot of data. So generate a lot of event, a lot of impact, a lot of not impact, but let's say damages if there's one. It's gonna all those events will be recorded by the system. But what we've put together is the new Bird's Eye application. So it's an application that you can have on your mobile phone, and it will give you the information in real time on your conveyor belt. If there's something to address, if there's nothing that requires attention, the conveyor will be green. Let's put it this way. If there's something that you need to look at, then you're going to get a message. So you have the condition of all your conveyor in real time in a way that it's easy to understand.
Yeah.
So it's a big improvement, on our side. So we are very proud of that.
So are you also collecting some data and then sort of simplifying data for them, or?
Yes.
Yeah.
Yeah, we do that, and we can also monitor the conveyor for our customer.
Right.
So we will get the message or the alert, ourselves, and then we will circle back to the customer.
Right. So correct me if I'm wrong. So the Eagle Eye is that's the whole monitoring system, and the Bird's Eye is that customer end user, sort of a simplified version. Do I have that right?
Correct. The interface. How do interface. How do we bring the information to the customer?
Yeah. Is that no? Do you have to go? I mean, you obviously have customers all over the world. Do you have to then go out and sort of update them? Like, how do you sort of get that into their systems? The Bird's Eye.
Well, it connects with our Eagle Eye system. So the Bird's Eye will connect to our Eagle Eye, and it's a fairly simple. It's all integrated in our system.
This isn't, you don't need to show up at 50
No.
different sites and integrate it in. Right?
Correct.
Yeah.
Correct.
Okay.
And the other thing that we did that I need to mention is, like many customers, they had the bad experience in the past with those steel cord monitoring system.
Okay.
Because one thing that I haven't mentioned is if you want to have rip detection, we're gonna inside the belt. You're gonna have a steel loop inside the belt.
Okay.
The loop will be, let's say there's a rip. The loop will be cut, and then it will send a signal once it goes over the the system.
Right.
So it doesn't send the signal.
No. It will send a different message. We will read a different message once
it won't read
gets magnetized.
signal, so it will shut down the conveyor system.
Correct.
Yeah.
Correct. Yeah. Well, the conveyors will shut down, but the issue that customer had with that in the past was that there was a lot of false signal.
Is that what you're referring to? The system would shut down? That false system, or?
So there's an inducer and inducing the loop, and then they will read a signal. And every time when loop comes, it will read the signal. But if there's a broken loop comes and it doesn't read it, but the system is expecting the loop is coming, and it doesn't read it, that means there's something wrong with the loop or belt. So it will shut down the conveyor system.
So people were frustrated. Sorry, I'm not quite.
Well,
why were people?
What I'm trying to say is, over the years, those loops that are inside the belt, they're made of steel.
Right.
And those loop, because of impact and flexibility that the
so
belt.
the belt
and
might be fine, but the steel
Right.
itself is
Right,
the loop
right.
is broken, but the belt is
Right,
perfectly
okay,
fine.
I got it.
So
Yeah.
they get those false alarm. So to overcome the situation where you get those false signals, we develop a highly flexible loop that we put inside the belt. So it's metallized fiber, and you're going to see on the video that this loop is so flexible. It's like a little fiber cord basically.
Right. So it's only now. That the whole belt would have to be damaged for that to be damaged.
Well,
more
it's going to send much less false signal.
Right.
Because we tested this loop with our equipment, and the regular loop, let's call the competitor one loop. Some of those loops starts to fade after 400,000 cycle.
Okay.
So the loop got damaged, but the belt was fine. And with the Flexi loop, we have stopped the testing at 1 million cycle,
Wow.
and the loop was still good.
Wow.
So it's going to be a very interesting system when we pair it with the Flexi loop.
Wow. Well, it's a lot. The testing with the bullet. That's going to be the standout moment.
Yeah.
In the interview. But I want to ask one last question before we wrap up this interview. Because we touched on it. I actually wish I had spent a touch more time on it at the beginning, but we had a lot of stuff to get to. So you're still manufacturing in the United States. Is that right?
In the United States and in Canada.
And in Canada.
Yes.
This is not the made in America question. This is the real, challenge that the industry is facing with the supply chain. How much of an advantage, just to be able to service customers right now, is it that you are manufacturing here? That must be a huge advantage all of a sudden to have that with this environment we're in.
Yeah, it is. Well, and not only do we manufacture our belt, but we weave our carcass ourselves.
Oh, wow. Okay.
So, and not everybody does that. So we weave our own carcass with, in Livonia, Georgia. So we control the process, from the beginning to the end. So we know exactly what goes inside our belt.
Wow.
So it's a good advantage. It's a very good advantage, and it gives us proximity. It gives us proximity to our customer. We're more agile. When it comes to adapt to customer need.
Yeah.
By the fact that we're close.
Well, and adapt to environment. The last 2 years have been
Correct.
insane.
Yeah.
Yeah.
No. That's true. That's
Yeah,
true. That's
yeah.
true.
So, yeah, no, I just, and again, I want to as we wrap up, I want to thank you for coming on and giving this technical information. It's just so easy on these interviews to sort of breeze past little details, and your team, you actually like going into them, so it just makes it more fun for me.
Well, and that's Akiko. If she has a lot more technical background
when
than
you
me.
were talking, I was watching just to make sure she was approving what you were saying.
He's the
She's
free
there to
face
make sure
and I'm
that
the brain.
she's there for the rigorous portion of the interview. So
No.
that's good.
Well, thank you both for coming on. I hope you're both back, because it was a lot of fun. Thank you.
Thanks for having
All
us.
right, thank you.
Thank you.
Thank you for watching the episode, everyone. This is one of those episodes that I hope everyone likes it, because I like it. I like to do these real dive in and learn something I didn't know. For instance, I didn't know a 44,000 foot conveyors could stretch 400 feet, so that was new information. Thank you to Fenner Dunlop. Thank you for all the support for everybody, and we will see you on the next episode of Mining Now.